So in this problem, we're told to consider the circuit in figure 1 and suppose that V1 right here equals 14 volts, V2 equals 5 volts, and then the current source is going to be 2 milliamps. And so we're going to determine whether it's valid and then a bunch of other things. Let's just go ahead and start with the first one. So is it valid? The answer is going to be yes. I'm just going to tell you that right off the bat. Yes, it's valid, or else we wouldn't be able to solve this problem. But yeah, and so how do we know it's valid? So essentially, since we have this thing and it's just one single line of current, right? As long as we don't have other currents, like two currents disagreeing with each other, in this case we only have one current, it's going to be valid. These voltage sources aren't going to impact anything. But yeah, so since there's no currents battling each other, like going in opposite directions, saying that the current is different, then it's going to be valid, right? So if we had a current going like this instead it was 5 amps, that wouldn't be possible, right? Because it's disagreeing. But yeah, so it's going to be valid. Now let's go and move on to the different parts. So this would be A. So yes, it's valid. Now let's move on to B. So B is asking us to determine which sources are developing and which are absorbing. And so in order to do this, there's a thing you need to know, which is called the passive sign convention. And so this is going to be the convention you're going to use throughout your circuits class. And different teachers use different things, but I recommend you use the passive sign convention just because I believe it's the easiest. So what is the passive sign convention? So we use this when we relate problems with current and voltage. And so in this case, we're going to be doing it with power. So we say that the power, this is a formula you need to know, the power equals the current times the voltage. And so another thing you should know by now is that certain things are going to absorb and certain things are going to dissipate, or right, so certain things are going to develop and certain things are going to absorb power. So how do we determine which are going to do which? And the way we do that is by using the passive sign convention. And so the passive sign convention tells us whether this power is going to be negative or positive. So if power equals negative, you need to know that that means it's going to be developing, right? So developing. And if power equals positive, it's going to be equal absorbing. Okay, so that's what you need to know. So how do we determine which is which? So the way we do it is we look at how the current is entering the specific source and the polarity. So let's start with here. So we know that this current is going to be entering here, and then it's going to enter the positive side. And so if it enters the positive side, you're just going to leave the formula the same, P equals IV. But if it enters the negative side, that means it's going to be equal to P equals negative IV. And so that's essentially what the passive sign convention is. And so keep in mind, if it's P equals negative IV, the power is going to be negative, right? It's not assuming that these values are positive, but yeah, so then it's going to be developing. But if the power is just this formula and they're positive, it's going to be absorbing. So if we look at our own circuit, we can determine which is developing and which is absorbing. So if we look at this source, right, we know it's going to enter the positive side. The positive side tells us we're going to use this formula. And we know since this is positive, it's 5 and 2, it's going to be a positive value, which means this 5-volt voltage source is going to be absorbing. And so let's continue it along. Again, it's going to enter the positive side, so it's absorbing. Same idea. And so for B, you're going to know that it's going to be these two, the 14 volt and the 5 volt, are going to be absorbing. And so since these are absorbing, we need it to balance out. So I just know automatically that the 2 milliamp current source is going to be developing. Okay, so that's that. Now let's move on to C. So we're going to use this in the second part of the problem too, because it asks us to change something, but that's a really important thing to know. You have to know that. So now we're going to find the total power absorbed and developed. So same thing, or same idea. We're just going to use this formula, but we're actually going to solve for the concrete values. So let's start with the power. Let's start with the power absorbed. So we know that these are going to be absorbing. So P equals IV. And so both of them are going to be positive because we entered the positive side first. So let's start with this one. It's going to be the current 2 milliamps, right? And so I'm just going to write that as 2 times 10 to the minus 3 amps, right? Because that's what milli is. And then multiply by 5. So 2 times 10 to the minus 3 times 5. 0.01. And this is going to be in watts since we're doing power. And so that's that. Let's do the next one. P equals IV. Again, it's the current through it times the voltage, 2 times 10 to the minus 3 times the voltage. With this, in this case, it's 14. So 2 times 10 to the minus 3 times 14. It's going to be point 0.028 watts. And so we want to find the total. This is the power absorbed in this one, power absorbed in this one. So if we add them up, that'll give us total power absorbed. So it's going to be 0.038 watts, right? And you can convert this to milliwatts, so 38 milliwatts. So that's going to be the total power absorbed, and we know it's going to be the same as the total power developed, just because they have to be equal. But if you want to verify it, I'm just going to explain how to do it. I'm not going to actually do the math, but essentially these are going to add up. So you're going to have 14 plus 5 is 19, and then multiply by 2, you're going to get 38 again, right? But keep in mind it's going to be negative because you're doing with power developed. Okay, so that's basically the first part. So your answer to, I believe, C is going to be 38. Or let me look. So yeah, so total power absorbed and developed are the same value, 38. Okay, sorry about that. Let's go ahead and continue. But essentially the answer to D is going to be 38 milliwatts, same as this one. But let's go ahead and focus on part E now. So E is going to be asking whether or not it's valid if we go ahead and change the polarity of our 14 volt voltage source. And so initially it was like this. So we're going to be changing the polarity, which just means flipping it. So now it's going to be like this and like this. But keep in mind, it's going to be valid again, just because if you change the polarity of a voltage source, it's never going to affect whether it's valid or not. So yeah, just keep that in mind. But yeah, so I believe it's E. So E is going to be valid still. And now let's go ahead and focus on F. So F is going to be having us do the same thing as we did in, I believe, B. Yeah, so B. But essentially, we're going to determine it whether with this change polarity. So keep in mind, we're going to be using the passive sign convention again. So essentially, yeah, so let's go ahead and determine which ones are absorbing and which ones are developing. So we have this 2 amp source, milliamp source. It's going to be entering the positive for our new circuit here. So this is going to still be developing. Or sorry, it's still going to be absorbing because we're entering the positive side based on the passive sign convention. So we know the 5 volt, and 5 volt is going to be absorbing. Now let's look at these other two. So if you look at this 14, now if we go along like this, it's going to enter the negative side. So this is essentially what changes in this one. So since it enters the negative side, we know it's going to be a negative formula. The power is going to be negative, therefore it's going to be developing. But yeah, so now the 14 volt is going to be developing. And then let's look at this one. So the 2 milliamp. So this is about, this is kind of intuitive, but what you should realize is that we know that the power developed by this source right here, the 14 volt, is going to be greater than the power absorbed in this one, right? And so since this one's greater than this one, we know that this has to absorb too, or else it wouldn't cancel out, because the power absorbed has to be equal to the power developed. So we know that this one's going to develop more than this absorbs, therefore this has to absorb, so they add up to cancel. So I know the 2 milliamp source is going to be absorbing. So let's write that. 2 milliamp is going to be absorbing. But yeah, so that's F. Now let's focus on the last part. So G. So G is going to be asking us to find the power developed in the circuit. So power developed, it's just going to be the 14 volt. Right? That's the only one that's developing, so we can just look at that one. So it's 14 volts, and then we know P equals IV. And so keep in mind it is entering the negative side, but when they want you to answer this, you just answer the magnitude of it. So essentially we have P equals IV, and we know the current going through it is 2, and then the voltage across it is 14 volts. So 2 milliamps times 14 volts. Right, and so keep in mind this is 2 times 10 to the minus 3. Since we want to convert it into amps, it's in milliamps. So this is going to be 28, and then times 10 to the minus 3, and since it's power, it's watts. So 28, and I'm going to convert this to milliwatts. But yeah, so this is going to be the power developed, and that's going to be G. But yeah, so basically you just got to, the main takeaway from this problem is understanding the passive sign convention, and then how to calculate power and like which sources are developing and which are absorbing. But yeah, just keep in mind if you enter the positive side, you're going to be absorbing. If you enter the negative, you're going to be developing based on the passive sign convention. And yeah, so this is going to be your answers, and hopefully you found this useful.